Welcome back to Reimagine 2020. I'm Yonah Hochhauser, and today I'm glad to be joined by Jordi Baylina, founder and CTO at iden3 and Hermez Network. Jordi, thanks so much for joining us.
Thank you very much for having me. It's a pleasure to be here.
All right, well, Jordi, first tell our viewers a little bit kind of who you are and how you got into blockchain.
Well, let's see. I'm a developer. I'm developing since I'm 12 years old. So that's mainly what I am, and what I love to do is to develop, and that's what I have been doing all my life, and what I love to do. I was introduced. Well, my first contact in the blockchain space was something like in 2013. I read the Bitcoin paper. I loved the idea. It was like very primitive. It was great. And at that point, I tried to get a little deep, just trying to, I was actually, I didn't know that, but I was trying to do some smart contracts at that point. I was just trying to play around with all this script language of Bitcoin. It was very disappointing because it didn't work anything. Most of the opcodes just they were not even enabled, and was hard. I went even to a meetup in Barcelona. I think it was the first meetup that happened in Bitcoin in Barcelona. But it was, I didn't feel comfortable with the people who was there. So, and I also had a lot of work in my old job. So I just put it a little bit apart. And it was back in 2015 that just because of a conference, a JavaScript conference, some guy just started talking about IPFS, a decentralized file system. It had nothing to do with blockchain, but it was something like, oh, that sounds interesting. And I remember that during that weekend, and I started doing research about IPFS and all these protocols. And I don't even know why, but I just saw the Ethereum project. And it was incredible because, these smart contracts that I was like spending a month trying to do it in Bitcoin. In 5 minutes, I just wrote a Solidity code. I deployed it on a testnet at that point, and it worked. And it was, oh, this is incredible. This is amazing. And here is where I start getting engaged. I was just just studying that, just taking my time from everywhere. I went to the bath with the laptop, reading things about decentralization, about blockchain, and it was like weekends, just all my free time, absolutely, and even my not free time. I was just absolutely immersed in this new world. It was incredible, and at that point, I was in contact with. At some point, I just landed to the DAO project. I just learned a lot from the smart contracts, and there I discovered all the community. It was not just a technology; it was a community behind, and what things happen, how the people get together. I remember. Well, the discovery of the community for me was very important. I remember it was just before the DAO. I was reading something about the Swarm project. The IPFS. Ethereum version, something. And I had some idea, and I just sent a message in one of those channels, and the responsible, Victor Tron at that point, the responsible of Swarm, just answered me I make a question of 3 lines, and he answered me like with a full page, explaining me a lot of things about how it works. And this community is amazing. It just, and it was just around that you get a little bit involved on that. And on the DAO, I did, for example, it was one of my first important smart contracts that I did was a fork of the DAO that was a liquid democracy for introducing liquid democracy in the DAO. And I was just doing it for fun. I published it exactly the same day that the DAO was launched. So absolutely worthless work for the community, but for me it was very, very important because I learned a lot about that. And after that, I redid all these smart contracts just to, instead of being a fork of the DAO, was just another smart contract built on that you can connect to the DAO. It was just compatible with the current version of the DAO. Was incredible. And then, all the DAO things, the people just expect like $3-4 million. They raise it $150 million. How the people just get crazy, and and all the social part of the DAO. That was, for me, that was really incredible at that point. And then is when the DAO hack happens, you know, it's like they're just good. But I knew a lot about that smart contract, so I knew a lot about that smart contract. So well, I just tried to investigate what was happening, and I was able to reproduce in the testnet all the attacks and all that. And well, I just contacted to the Slocky people, say, hey guys, I did it that. And for me, this was one of the most incredible experiences in my life. They just put me in a call. It's like I was like the last random guy that appeared in that in that call, and they were just rescuing $100 million. And it was like, you know, my old life was very boring. You know, I was just doing software in a company, you know, just that. And here is like a set of hackers just moving around and whales, sending like millions of dollars. And I was just listening in there. It was like the last guy. I was listening that, but it was, well, this is a movie. You know, this is something that I cannot believe what's going on. And I remember that after like 4 or 5 hours or 6 hours that happened in this call, they had to rescue like $100 million. But the last $4 million, they were not able to transfer. And here is where my opportunity came, and say, hey, look, I did my test. I tested in the test. It works, but maybe it doesn't work for you. Maybe I can try. And some random guy that I don't even know who were, you know, it's just some alias. They just sent me something like $3 or $4 million. Well, it was a little less, but but in any case, it was like much more money than what I get in my full life or something. It's like was some crazy amount, just absolutely trusting into me, absolutely. And I was just trying to hack, and actually, well, it was a little harder, but actually I was able to extract to rescue this last $4 million of the DAO. And this is just life changing. From there, I was just in this group of white hats, just trying to fixing all the mess up of the DAO. It was like 3-4 months, very, very intense working month. And and from there, of course, I just, they just fired me from the last job. But it's not a fire, it was just, but I was not doing anything else, you know, my life was already there. So from there, I just start. And from there, I'm just full-time in the blockchain. From there, a lot of projects we can talk about, but that's how I get introduced to the blockchain. I know it's a little bit long, but it's I think it's an amazing story, and so actually it's the story of my life. You know, for me, it changed absolutely my life after these events.
Yeah, well, we hear that so often in this space is how important a community is to these projects. And I love talking to developers because it seems like, you know, a lot of people first got hooked when they read the Bitcoin white paper and they saw, wow, you know, this is really interesting both on a, financial level, but also on a technical level as well. And so it's interesting to see how, who follows what projects. And it seems like more I don't want to say not in a bad way, but the anarchists or the people who are self-sufficient have really went towards Bitcoin, you know, as a way of financial freedom from governments. And a lot of the developers saw Ethereum, like you mentioned, when you were trying to code a smart contract, it was just so much quicker and easier for you for Ethereum. So it seems like a lot of the developers really got attached to Ethereum and built a really wonderful community that's made incredible things. But it seems like Ethereum has become too successful for its own good. You guys did such a good job of building on Ethereum that the Ethereum network kind of can't handle it. It's become very congested, high gas prices. And so it seems like you'd actually try to solve that as well. You try to solve the scalability on Ethereum. How do you plan on doing that?
Well, Actually, this story, you know, when I decide that I want to be in this space, I'm an engineer. So what I've been doing all my life is to bring technology to mainstream, actually to solve people's problems. That's what an engineer is at the end. Okay, then you decide what you want to do in the space, and you decide, okay, we need to bring this technology to real cases. Okay, and this is, you know, this is like, okay, there is a bunch of things that you need to do before the things goes, but one of those, and it's one of the most important, is that needs to scale. If this does not scale, we don't go anywhere. It's worthless. It's useless. Well, maybe it's useful for a small set of people, but doing some sushi stuff. But that's it. You know, it's collapse. You know, this is. So we start working on scale. At that time, there were no. I was very skeptical in the scaling. You know, there was this sidechains story. There were, you know, these Polkadot and you know, all these XDAI, all these proof of authority networks. This is the technology that was at that time. Then there was the Plasma team that was based with this gaming stuff. But I was very skeptical at that point, and was at the moment that we start working with zero knowledge, and we discover the Rollups. That is like where the light turns on and says, well, yes, that's the solution. It's a long trip. It's not a solution that can be implemented tomorrow. It's a solution that, you know, it's a technology, it's all this zero knowledge technology that needs to be understood, developed, bring to production. When you want to scale, it's not only about only the zero knowledge, you know, it's like there is a bunch of things that you need to build. We are building Hermez right now, for example, and it's not it's not only this generation of the proof. Now, handling 2,000 transactions per second, so you cannot handle that with a Raspberry Pi. You need a huge infrastructure just to accept. So just making a single server that accepts 2,000 transactions per second and verifies a signature and nothing else. Just doing that is a full engineering project. It's like just a, so scaling is not, you need to scale everything. We know how to build it. Of course, there is some triggering technologies that allows that, but the rest of the pieces needs to be done too. So this is mainly what we have been doing. So my switch point is, okay, this is what we have to do. We start working a lot in the zero knowledge. We have been doing a lot of research and have developed tools, important tools like Circom and Snark.js that in some way take this technology and try to put it to the, let's say, the standard developers, you know, that a random developer can understand what's a zero knowledge, can build a circuit, can create their application using zero knowledge and all that stuff. And we are building Hermez, which is a full network for payment systems that scale with 2,000 transactions per second. That's what the path for bringing. And it's like, it's not a proof of concept because it's a real network, but it's like a proof that, okay, that this technology can be used really to scale blockchains. And that's, from the conceptually, that's the importance of the Hermez project. It's just bringing this technology and proving that it really can be used for scaling blockchains. And that's of course, this is not the only, and it's not the only problem that needs to be solved in the space, but this is one of the problems that needs to be solved, and here is an important path that we are working on.
Yeah, because I mean, no one could deny that right now, with the DeFi boom, it has brought a tremendous amount of capital and value into the space, but also exposed this big issue of you know, a lack of scalability, especially on Ethereum. Now, you mentioned that, you know, it isn't only zkRollups like Hermez that are trying to fix the scalability problem. There's Plasma side chains, you know, and there's Polkadot and a bunch of others. What is it about zkRollups that you find make it a better scaling solution than those other layer 2 scalar solutions?
Mainly is with a zkRollup, you don't need to build a full blockchain. You're using the layer 1. This is a layer 2 solution. So it's like you don't need, but creating a blockchain is quite difficult. You need maybe a proof of work, proof of stake, and you need a lot of, you need to implement a lot of things. And you are even, you can have a lot of attacks. And this solution is quite clean. It's a solution it's very simple. The concept is quite simple. I think it's very easy to understand. It's based on the layer 1. So you don't need to introduce many concepts. You are just getting a state, getting transactions, and betting the state. You are doing exactly the same that you would do in a normal blockchain, but you are doing in the same layer 1 blockchain. So this idea, it's important. And also the concept of splitting what's the data availability problem and the validation problem. This is the key piece, and this makes a lot of sense.
Are there any limits to zk Synarchs and zkRollups in terms of a solution? Is it like, okay, it fixes this problem, but it also creates that problem?
There are limits, but I would say that we are quite far from reaching those limits, and we have some, and there are even solutions to those limits. So it's, I would say that at this point is far away. So the limits are more the computational limits of the computers, so the technology itself, that the mathematical or the theoretical limits that we have. And as I tell you, all these technologies, zero knowledge technology, it's it's in constant research, and there are very new as I tell you, there are new developments that are even solving this. So the research is going his path. We are just taking we are taking in Hermez, we are taking the technology that was already used in Zcash.
Yeah.
So it's a technology that's available, that's there. Okay, but during these 4 or 5 years, there are new things that are happening that are quite interesting. Plonk, Halo, of this new generation of zero knowledge that probably will be the replacement of this piece. But first we need to scale all the other pieces and putting them on the system.
Well, you mentioned that Hermez could do 2,000 transactions per second. That's actually more than in one I saw than Visa network can do in per second. I think Visa is 1,200. I'm not sure if that's true, but Hermez, how much is Hermez at 2,000 right now? Is it currently able to process 2,000 transactions per second?
Yeah, this is like a little bit the theoretical limit with the current gas, with the current gas limit, with the current block gas limit that we have in Ethereum. There were news like last week that maybe the block, maybe they could be increased and that. So this, you just multiply that for this factor on this. But it's also a theoretical limit. This is 2,000 transactions per second.
Yeah.
That would be if the full blockchain is just used for this.
Yeah.
So this needs to be shared with the other applications on the Ethereum. So the limit is like a kind of theoretical limit, but this limit can be increased. Probably next version of Hermez already will have easily 4,000 transactions per second. And when the new, when the introduction to the BLS smart contract, precompiled smart contracts or something equivalent are introduced in Ethereum, we can multiply that by 16 easily. It's like, there are some, this is like an initial limit, and this can be increased quite easy in the next 2,000 transactions per second is like 2 orders of magnitude of the current Ethereum So it's an important step. And as I told you, it's not only about the proof generation, it's about the infrastructure. You need to build block explorers for handling all this quantity of transactions. You need to, the validators technology. You need to, it's like there is a lot of pieces that needs to be built in order this to enable. And this is like a new generation of just an important step in the blockchains. Mainly it's taking, a blockchain that as we know right now, and putting in mainstream, it's just multiplying that by 100 or by 1,000. That's like making it huge. And this is the technology that people is working right now. It can not be done in one day. As I told you, it's just a process that's doing. And
well, you mentioned that it will be very computationally intensive, and you have to upgrade the whole infrastructure. Does that mean that node operators will have to have, supercomputers? What does that necessarily mean?
No, how it works. This is very related to how it works. A rollup. A rollup there is the concept of this coordinator. Anybody can be a coordinator, but coordinator actually is the equivalent as the miner. It's like the one that really do the work. And in a rollup, this is very important because first, it needs to process all these transactions. As I told you, this is not a Raspberry Pi. This is probably a huge infrastructure.
Is it a warehouse or is it a single gaming desktop PC?
It probably would be. It could be maybe a set of servers. It can be in a warehouse. It can be in a data center. It can be in a.
But is it something that a private individual at home could do, or it has to be like a group that's investing?
I would say that it could do, but in order to be profitable, you need to, unless you are able to process this quantity of transactions. So unless you do an important investment in hardware, you can rent it too, but unless you are having this important infrastructure, it will not be profitable. If you are actually, what you are doing is you are buying like 10 minutes slots, and during these 10 minutes you can process as many transactions as you can. If you have a lot of hardware and you can process a lot of transactions, this is going to be very profitable for you.
And will ASIC, right now a lot of miners, there's mining, will ASICs be particularly good at this, or will this be something that CPUs?
No, it's not, at least not in the way that we are not mining anything. So we need to do computations, and maybe ASICs are good in order to create some computations faster and cheaper. That could be interesting, but it's not, I would say it's not as important as mining. Mining is just about hash rate. It's about just having that. Here not. Here is, of course, you need to compute the proof. The proof is like computing intensive process. If you are able to minimize the price of this, you will be in a competitive advantage with the rest of the coordinators. So you will get more money. You will have so you have more chances to earn these slots, and you will get more money. So, but if you are a normal user with a normal PC at home, you can buy a slot, but it would be super expensive, and you will not do anything. So it's not going to be profitable.
So it seems like similar economics to the mining system, where it's a different setup, but either way, it's the people who are willing to invest in computational hardware that are going to be the ones who are profitable and getting the rewards for that computation.
It's quite, the idea is very similar. The difference is that because the limitations, for example, in an Ethereum block, anybody can, because there is a limit of gas sites, and this is designed that way. There is a limit of so you cannot put more than that. And what you can put there with any, I would say, average computer, you can process this block. Okay, so this is what's Ethereum about. That's a limitation, and because it's limited, any computer can compute this part. But at the moment that you want to scale, at the moment that you want to put in this time frame, you want to put millions of transactions, or if you want thousands of transactions in this case, somebody needs to process. And here is what Rollups is about, is this asymmetry. So the Rollups is, there is somebody that's computing, that's validating the transactions and computing this proof, and once with a hard, with a computer intensive, is creating this proof. But then the verification of this new state, you just have the root of the Merkle tree of the new state.
So very small.
Very small. It's and the verification is very, 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 very fast.
Now, one of the reasons why there is that gas block limit on Ethereum, and even just the limit on Ethereum is protect against people spamming the network. What's stopping someone from doing that to the zk rollup, to that scaling solution of just spamming that with very complex computations and slowing it down as if they were to do to the Ethereum blockchain itself?
This is what I was explaining. It's like the proof is compute once for a coordinator, and the consensus layer. So the one that's so the rest of the people in the network is just verifying, and it's verifying this proof very, 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 very fast in constant time. So, and this asymmetry between the coordinator and the validators is what really makes the things scale. There is another important thing here. That's another important thing here is the data availability problem. In the current rollups, we are putting this data in a very compressed way in the same network, in the same blockchain. So it's just a minimal data. It's just I think it's 11 bytes per transaction. So, and this is very cheap. And this is, it's not even counting as a state. It's just part of the transaction. That's what we are doing. But this data, but it's important, because if the transactions are not available, then the system doesn't work. So data availability is the other part that's problem. And here is, for example, where Ethereum 2.0 is doing a great job.
And and my question is, I was looking into it, and my knowledge is a little lacking on zero knowledge, ironically enough. What the hell is the perpetual powers of Tau ceremony?
Okay, yeah, this is just.
Is that a pagan religion going on? What's going on?
Yeah, it's a very bad thing. It's like this is one of the technology that we are using is zkSNARKs. zkSNARKs is. I would say it's an unbeatable technology from the zero knowledge. So it has the most important properties for the blockchain are great. The proof computation is very good. The verification time is constant. So no matter, this is the important thing, no matter how many transactions you have, that the verification is constant time. The size of the proof is very, very, very small. So if you see the parameters of the zero, it works great. Okay, so it's perfect. And I would say even the new generation of the zero knowledge technologies that are appearing, zkSNARKs are still better. They are getting closer to zkSNARKs, but zkSNARKs still is the best one. Okay, it's the one that has these properties, a better one. What are the drawbacks? What are the problems of the SNARKs? The problem of the SNARKs that they need this trusted setup ceremony. Trusted setup ceremony means that once in your life, you need to do this ceremony, and this ceremony mainly what it means is that, well, we need to create a random number. We need to do some computation on this random number, and then we need to this random number to disappear, to delete, and it's impossible to mathematically prove that you have deleted something. Okay, so what we do here is it's a multi-party computation. The idea is that we do a ceremony with as many people as we want, and the idea is that I get a random number and I delete that, and then the result I send it to you. You get your random number and you delete that, and then you send to something else, and this is like this is a ceremony on that. Okay, and as far as there is one of all the ceremony that just is good, then the system is perfect. It's okay.
Yeah.
Okay? So
Then you know for sure it's a real random number that the system is based off.
Exactly. So as far as there is one that really forgets this random number, so this is in Zcash ceremony, for example, the second one, the first one were only nine persons running this ceremony. The second one, I think there were like 70 or 80 persons that ran this ceremony. So well, it's right number. Okay, so this is the important thing of the snarks. Okay.
Yeah.
So okay, this is important to know that there is this drawback. Okay, but this ceremony has like two parts. One that's common for any circuit, for any application. Okay, this is what we call the powers of Tau ceremony. This is it's like what we call it the universal trusted setup. You know, it's a ceremony that's valid for anybody. It's run once and that's it. That's useful forever. Okay, and then there is what we call it the phase 2. That's specific for each application. It's a smaller ceremony, but you need to do exactly the same. So powers of Tau is this ceremony. And actually, for example, there are a lot of this new generation of Zcash snarks, for example, Plonk or Halo, that are based on this. So they are still based in a trusted setup, but they are based only in the powers of Tau. So in the universal ceremony, it's a universal trust. They don't need this second ceremony. This is, for example, one of the improvements that the technology is doing. We are still using the first one. We need to run these two ceremonies. The first one is already done. This ceremony has been running for 2 years now or something, or 1.5 years or 2 years, the DJ and so on. And it's still going on, so you can still contribute on that. But what we did is, okay, we get the first 54 contributions, where a lot of people, from Vitalik, Kobe. Well, there are many people, many known persons in the space and companies that has contributed to these powers of Tau. We got it at number 54. We run here what we call it a random beacon. So that's mainly this is a technicality just for the last one not to have advantage on this. So we just close this ceremony, and this is the perpetual proof of Tau, and this is done. We already did this part, and we already have this first part of this first ceremony done. Now we are preparing the circuit, and we will run the second ceremony in the upcoming weeks.
Now, this all comes from a problem that a lot of people don't realize, where when you're dealing with deterministic systems, it's impossible to create a truly random number, correct? Is that why you have to do the ceremony, because you can't create a random number within the system itself?
No, not really. It's more about because we need to guarantee that a concrete random number that exists at some point, and we make some computations. Imagine that you create a private key, okay? You compute your public key, but then this private key needs to be deleted. Nobody needs to know this private key. How you do that? It's like how you. This is what's about. And so all this ceremony is just in order to prove that a random number is unknown. So you have a public key, that the public key is valid, that you have this key that's okay. It was generated at some point, but right now it's unknown and nobody have access to this. And this is what's about. This is what it's a technicality of the zero knowledge. There are, for example, there are Starks. For example, the Starks technology, they don't need this. They don't even need the trusted setup at all. They are just based. And then they have other problems. Maybe the proof is bigger, and there is some other advantages and disadvantages because there are different models. But for example, this trusted setup, they don't require this. This is an improvement there. I hope that maybe at some point there will be the perfect Zcash snark. But there is right now, there is no perfect. It doesn't exist yet, the perfect zero knowledge tech.
And how does proof of donations work?
Yes. Here is a proof of donation is so an idea is, how do you select who is the coordinator? There are many coordinators, and who is select the coordinator? Well, the way to select who's the coordinator is, okay, in order to be a coordinator, you need to bid. So who is willing to pay more for this 10 minutes block? Of course, who's going to be more? The one that has maybe better infrastructure and that has that can compute more transactions per second. So these are the ones that are going to get advantage on that. So they will bid on the slots, and what happened with the money they bid? Well, this is we consider that a donation, at least a percentage. What we are doing is, who's bidding? The way whoever is proving that's willing to pay a bigger donation. This is a proof of donation. It's like we call it this way.
And where's the donated money going to? What are you guys doing with that donated money?
We are 40% is just burn. So the token is just born, and this is important because if not, it could be some kind of cycles on that. 40% is going to donation. Donation right now is going to it's going to layer one. It will go probably to the Ethereum Foundation, and probably the Ethereum Foundation will put it in a quadratic funding in Bitcoin or something like that. But it's something that we will not control where this how this money is spent. So we just control that. We just control that it goes to layer one. We need to build. We need to understand that. We need to understand that we are running on top of layer one. So layer one must continue work, must continue improve, and it's very important. So, and we need to self-sustain layer one. So in some way, we are doing that, and I hope that all the layer two solutions will have some equivalent mechanism in order to fund, in order to self-maintain the layer one, and then the remaining 20% will go to the governance token holders of the system.
Now, you mentioned that you're all serving layer one, and you're trying to support the further development of layer one because you all rely on the layer one.
Absolutely.
Yeah. Well, that layer one is Ethereum, and they've been promising, or they've been trying for so long to launch ETH 2.0. Now, once they do launch ETH 2.0, and that switches the proof of stake and sharding, and actually scales, doesn't that render all these layer two solutions useless? I mean, why would anyone use your solution or Plasma or really any of the solutions if ETH 2.0 launches, it works, it scales? Aren't you kind of shooting yourself in the foot?
No, no, and I will tell you what. So Ethereum right now, the phase 0 is just this proof of stake and this beacon network and so on. This is just like a preliminary step. The first step is sharding. Okay, sharding is very important for Rollups because, as I told you before, it solves the data availability. So the idea is, one of the limitations that we have right now with the Rollups is that we still need to put the data on chain, and actually this is the limit that we are hitting now. It's like we need to put these transactions, we compress them, and we put it on chain. So, and the chain is limited in some way. So okay, we can compress a lot, but at the end there is this limitation there. And this is just for data availability. The only thing we need the only motivation for doing that is that this data is available. For example, there are some systems like Validium one, for example, the DeFi with Star Wars is working on that they are not putting this data on chain. They are putting that in some federation of these servers, so they can like scale like infinitum, because they put a proof in this proof, they can put as many transactions as they want. This is the thing. Well, in Ethereum 2.0, when there is sharding, this is very useful because you will be able to put this data in any of the shards, and you will just create a proof. It's like a proof that this data is already accessible. Maybe in different shards, but it's accessible there. So just sharding, this is very important just for the rollups, just because it solves data availability. But going further, in the next step of the Ethereum, they are talking a lot about the execution environments. Well, execution environments at the end are like rollups. It's a rollup is a kind of execution environment if you want, but it's like Well, it's that. It's like the state is spread in the shards, but actually what's executing is a rollup. So actually, Ethereum 2.0 can be think as a set of rollups in some way. So it's absolutely complementary, and it's parallel. So what now are rollups or layer 2 solutions in Ethereum 1, in Ethereum 2, they probably will be this execution environment. So it's a work that in some way it's a work in parallel. So everything that comes from here is usable there, and there is a lot of synergies there. It's, of course, we are building all together all this. It's a work in progress, just we are working on, but it's not all the work. I would say that very few work will be throw it away. What's doing.
That's very
no, as I told you, just developing highly transactions block explorers or monitoring systems with this quantity of transactions. This is going to be very useful also for Ethereum 2.0. So it's like it works very much together. We will see how this evolves also too, because this needs to be put. And as you told before, all this here is the value of Ethereum right now is so huge that this is you are moving a machine that's, I don't know how much is that, but it's like $30 billion value, like that, or $40 billion. It's like you need to be very careful what you're doing, and that's probably this may slow down some steps in there. But people is moving forward. Ethereum 2.0 right now already is a reality. This Medalla and the Beacon, this works quite well. So it looks like this will be launched. This is like the first step. With this, just building the shards. Well, it's the next step. Maybe it will take some more time, but it's quite straightforward. With these shards already, the rollups will help a lot. Will improve a lot, and then it will be this last phase of how we convert these rollups in layer 1 to layer 2 and some these migrations. And this is where we need to discuss how do we do that. But even that, for example, for rollups, we expect to have many upgrades in some way, because we are very early stage. So at least at the beginning, we will have some upgrades. So maybe one of the upgrades is just to move to Ethereum 2. So we'll see in some way how we coordinate. It's like a little bit dark zone yet. We need to launch and see how it works all together and what's the current status of how the different pieces performs. And but this is a little bit the plan. It's like I know that when you are doing, maybe if you're outside and you see it's a lot of research, and you see, but Ethereum had to be launched like 2 years ago, and so yes, I agree. But when you really see the work that's been doing, how it's been doing, how it has been evolved, and even maybe there's some turns, sometimes when the research goes in one direction, and in one direction you see that's not the way, and then you go back and you take another path. And this is our normal. We are researching a lot. Ethereum for me it's not a lot. So Bitcoin is more it's a finished blockchain. It's there. It's what it is. It's great. It's the first one. It's perfect, but it's already there. Ethereum it's a research. It's more a research environment. It's worthy, probably too much worthy for research. Research environment, and it's sometimes a little bit scary, but very, very, it's very, very important. And I would say that's not all, but most of the work in the blockchain, in the research blockchain space is happening directly or indirectly.
Well, like you said, it's kind of the problem, because they've been talking about Ethereum 2.0 for so long, but there's been so much value on Ethereum that it's kind of scary. You have to be super, super careful and sure there are no bugs when to transfer over to the new chain. But you said that they're almost there. When do you think that Ethereum 2.0 will actually go live, mainnet and all?
Well, what's clear is that the first step, the step 0, the beacon, this looks like quite immediate. I don't know. It looks like it's a matter of months, if not weeks. But it's like it's quite it's quite will go quite fast. And I don't know, maybe it's, I don't know, expect 1 year, 2 years, 3 years, maybe 4. I don't know.
1 year, 2 years, 3 years. You know as well as I do in the blockchain world. That's 100 years in the real world. I mean, so much could change in 3 years.
Yeah, it's what it is. But you know, the research is not something that you cannot accelerate much. Actually, I think Ethereum is doing a great job, at least in the research. It's a lot of researchers, a lot of people just thinking and working in a coordinated way. A lot of the, you know, I would say it's the most of the improvements in the space comes from the Ethereum research, directly or indirectly, in some way or the other. And it's doing a great job for the blockchain space in general. You know, it's just a lot of things are happening there, and a lot of the other thing is, okay, the Ethereum network and how this research is applied to the Ethereum. And this is, well, it takes its time. It's, of course, there is still the problems. You just need to just connect to some of the core devs and see what the people talk and what's the status of the, you know, of the. There is, of course, there is problems like any enterprise, but I think it will, seeing from outside, I'm not from the Ethereum Foundation, I'm just a community member, but seeing from outside but quite close connected with many of the people in Ethereum, I think they are doing a great job. And yeah, it looks like a delay, but I tell you, they are not, at least most of them, at least the people that I know, they are not sleeping. You know, they are doing a lot of work and a lot of research. We will need, and I agree, there is a lot of unknowns that needs to be solved, and we will see. But I expect that right now, there was a moment maybe that was a little bit of uncertainty, you know, that these changes of path. But I would say that since 1 year ago or so, the path is quite defined. It's quite well defined. Still, there is some unknowns in the middle, but the general path is quite well defined. Right now, the teams are set up and they are building these clients, and so this first step 0 is very important because it's like an important milestone for all the people that's been doing work in the Ethereum 2.0. It's having like a start, but this is, I think it's a machine that has been taking a while to put them to start working, but right now I think it's going to be quite unstoppable.
Well, I mean, that's great to hear, you know, especially from someone who you know is quite connected in the community and understands on a development level. Like you said, you were there. You're one of the people they turned to during the DAO hack. I mean, clearly you understand. So Jordi, it's been an honor speaking to you, really getting to, at least for myself, and I'm sure the viewers, got a better understanding of zkRollups and the excitement that comes along with it. So I appreciate you taking your time and joining, speaking to us today. And for all our viewers at home for Reimagine 2020, I'm Yonah Hochhauser. Thanks for watching.